if you remember, it'll cross the x-axis. There are three possibilities. It could have two x-intercepts. That looks something like that.
One or none.
It could have one x-intercept. That happens when the vertex is on the x-axis. Or it could have no x-intercepts, where it opens up and it's always above the x-axis, something like this. So those are the three possibilities that can happen. Now, how did we find the x-intercepts? Well, we first started putting it in our calculator, and we just used a table, or we used that find the zeros button on the calculator. Then we started factoring. So when we factored, we set two things multiplied together equals 0, and then we were good to go. Whatever those two solutions were, those were my roots, my solutions, my x-intercepts, my zeros. Right? They all mean the same thing. What we worked on the last few days is what happens if it doesn't factor. Well, we can find the x-intercepts by completing the square. That was that whole process. Make the a value 1, half the b term, square it, add that to both sides. And then I also showed you the little hack to know what it factors to be very quickly. Remember, whatever we get when we half it, it's going to be x plus that number or x minus that number squared when it factors. The part that we've been focused on most recently has been finding the x-intercepts of a quadratic. So where are the zeros or the roots or the solutions? I'm finding the point on the graph where the quadratic function crosses the x-axis. All right? They could have two x-intercepts, like this graph does. It could have one x-intercept. That happens when the vertex is the x-intercept. Or it could have no x-intercepts. Right, if it looks like that. And so the way we first found the x-intercepts was we put it in our graphing calculator and we calculated it. We looked at it on a table to find where the y value was 0. And then last week we started by factoring quadratics. So if I can factor it, make it be two things multiplied together to be 0, then those two things are the x-intercepts. Set them both equal to 0 and solve. And then the last thing we did, what if it didn't factor? Well, we could find them still by completing the square. Right? We're still finding x-intercepts when we do this. How do we complete the square? We made the a value 1. Then in our heads, we took the b term. We halved it, we squared it, and then we added this value to both sides. And then I also taught you the little hack, the little trick for how to know what the left side would factor to be. Right? When we half it, whatever we get when we half it, it's going to be x, either plus that or minus that, depending on what the sign is. Okay? Now, factoring. Does factoring always work? No. Does completing the square always work? It does. Okay? Completing the square will always work. But is completing the square a pretty long process? It can take a little time. Not quite as easy as factoring. Correct. So today we're going to learn the third and final way that you can solve a quadratic. And this way will work every time as well. It's just like completing the square. It works every time. Now, this first thing I'm going to go through is I'm going to show you where the formula comes from. Because we're going to be given a formula for finding the x-intercepts of a quadratic. So you do not have to copy this part with me, but I do want you to pay attention and see if you can follow along with what's happening. So let's say I have a quadratic equation. Those are in the form of ax squared plus bx plus c equals 0. That's what a quadratic looks like. It has an a, b, and a c. Anytime you've ever seen a formula, that you've ever plugged into a formula before, it's because somebody has taken the general form and solved it. So what we're fixing to discover is the quadratic formula, and the way we're going to do that is we're going to complete the square of this general quadratic form that has no numbers in it. What are A, B, and C? They're just any number. Anything you want them to be. That's how this works. So if I had to complete the square of this quadratic, what do I need to do? I need to first make the A value 1. It's not 1. I don't know what it is. It's A right now. So what would I need to do to get rid of this A? I would need to divide everything by A.
And that's to get rid of the A? Yeah.
That's how we did it before. If you'll remember, we did some problems like that previously. If I had 4x squared plus 8x plus 32 equals 0, and we had to complete the square, first thing we had to do, we had to divide everything by 4 to make the A value 1. It's the same thing here. I'm dividing everything by A to get rid of this A value. And it'll make it be a 1 that's in front. Okay? So now, what happens when I divide everything by A? Well, A divided by A cancels. So I'm left with x squared. This part here, this is, we're going to write this as B divided by A times x. It's the same thing. This is just the coefficient, is B over A. Right? If this was an 8x divided by 4, we could write that as 8 over 4, which would then simplify to be 2. We're just leaving it as 8 over 4, or B over A. And then I've got C over A. And then what's 0 divided by anything? 0. So 0 divided by A, we can leave that as 0. Okay, that one will simplify. So I've made the A value 1. Now this part we do in our heads. Take our B term. Okay, well what's the B term now? It is B over A. So in our heads, half it. So what is half of B over A?
B over A?
It's not. How do you half something? We could divide by 2 or multiply by half. So my B term is B over A. If I'm halving it, I'm multiplying it by a half. B times 1 is B. A times 2 is 2A. Oh, that looks familiar. Half the B term. If I half the B term, it's B over 2A. That goes in my head. Now square it. So what do I get if I square B over 2A?
B squared over...
It's going to be B squared over...
2A is 2A squared?
So you got to square the 2, which is 4, and you've got to square the A, which is A squared. So what have I done? I've taken my B term. I halved it. I squared it. Okay, now what do I do with this number? We add this value to both sides. So I need to add B squared over 4A squared to both sides. So let's do that now. I'm going to have x squared plus B over A times x plus B squared over 4A squared. Right, I've added it over there. Then I've got the plus C over A. And now I need to do the same thing to the other side. If I've added B squared over 4A squared to one side, I have to add it to the other side. So this is B squared over 4A squared.
So
Again, you guys don't have to worry about copying down every one of these little things. If you can understand what we're doing, you're not ever going to have to do this again in my class. Okay? Can you understand our process, what we're doing? I'm just completing the square, getting to this point. Okay? Now, this is my trinomial that I know what it factors to be. Right? These 3 terms. I can factor that. That's the little hack, the trick. This C over A is the constant number. It needs to get moved to the other side. I need this over there. So I could subtract C over A from both sides. Okay, so now I have x squared plus b over a times x plus b squared over 4a squared equals, and now I've got b squared over 4a squared minus c over a. Okay, now let me take a little bit of time. I want to simplify one part of this very quickly, and then I've got to go to a new slide. So forget the left side for a moment. Let's look at the right side. I'm subtracting fractions. What must happen when you subtract fractions? So if I told you to subtract a half minus a fourth,
Oh, you have to have the same denominator.
you must get a common denominator. When you subtract fractions, you have to have a common denominator. Do we have a common denominator right now? No, they do both have an A, but they're not a common denominator. So to get a common denominator, again, I'm just going to do a little bit of scratch work over here. What would go into both of these? Well, for 4 and 1, the common denominator needs to be 4. And for a and a squared, the combinator needs to be a squared. That's the lowest one that they both, nope, I'm saying it backwards.
It'd be A, because that's the lowest one both of them get to.
That's correct. But the common denominator needs to be a squared. I'm trying to think how to explain it. If I had 3 over x plus 3 over x squared, I can't ever make one go down. So like think about if you had a half plus a 4. I can't make this 4 come down to a 2. I have to make the 2 go up to the 4.
Wait, so can you not just multiply the other problem by it? You can multiply 3x by 1x. 1 over x. So
X over x. That's what we're fixing to do. That's what we're fixing to do.
Yeah.
X over x.
Yeah.
Okay, so here, to get the common denominator, it's going to be 4a squared. Well, this already has a denominator of 4a squared. So I don't have to worry about it, but how can I make c over a get a denominator of 4a squared? I need to multiply by 4a, because 4 times 1 will give me 4. A times a will give me a squared. If I multiply by 4a on bottom, I have to multiply by 4a on top. So this one doesn't change. This one is still b squared
So it'd be 4ac over 4ac.
minus 4ac. So you see this b squared stays the same. And then over here, 4 times a times c, that's negative, is going to be negative 4ac. All over 4a squared. This is a common denominator. So I can write it as a single fraction. So now, just clean this up very quickly. I have x squared plus b over a times x plus b squared over 4a squared equals b squared minus 4ac over 4a squared. Everybody go here, get into here. Now I'm just going to go to a new slide. I'm going to copy that down again. And then if I go back and look, it's going to be, what did I get when I halved it? I got b over 2a. Didn't mean to click that. So I've got x squared plus b over a times x plus b squared over 4a squared equals, and this was b squared minus 4ac over 4a squared. All right, just copy down again, the last thing I had. Now, I've got everything to one side. This is the thing that factors so nicely. It's what's in the left. So what was my hack that I used to know what this factors to be?
Is it x plus b over ax?
It's going to be x. It's going to be x plus b over 2a squared equals b squared minus 4ac over 4a squared.
Everything's simple other than having to get the equal thing, like the thing, the b squared minus 4ac thing.
Okay? Do you see how I'm still just completing the square?
Yes.
That's all I'm doing. It's the same process. Now I have a single x. There's only one x now, so I can solve for this one x. So why is the x not by itself? Well, it's being added to b over 2a, and it's being squared. Which one do you get rid of first?
Square root.
The square by taking a square root of both sides. The square root and the square cancel, and I'm left with x plus b over 2a.
And you subtract.
In a second. All right, I took a square root of the right side. What happens when I choose to take a square root? I have to account for the positive or the negative possibility. So it's plus or minus the square root of b squared minus 4ac over 4a squared.
One of that is.
I do know what that. I'm just taking the square root of both sides. Is all I've done. Now here's a little thing we haven't worked on much. If I'm taking the square root of a fraction, I can write that as the square root of the top over the square root of the bottom. Now the reason I might want to do that, again, I'm going to do a little scratch work over here. This is the square root of the top over the square root of the bottom. The reason I might want to do that is because the bottom is a perfect square. What is the square root of 4a squared? 2a. So I'm going to simplify this. The bottom has became 2a because the square root of 4a squared is 2a. The top, it didn't simplify, so I'm going to write it as plus or minus the square root of b squared minus 4ac over 2a.
But, never mind. B squared is a perfect. No.
It is,
But you can't simplify 4ac.
but you can't simplify when things are being subtracted. Because if I ask you, what is the square root of 5? What number times itself is 5? Exactly. But we could write 5 as 4 plus 1. Don't you agree? Well, if you could do that, what's the square root of 4?
2.
The square root of 1. So you're telling me the square root of 5 is 3? You can't break apart a radical over addition or subtraction when it's multiple terms. You can only do it if it's multiplying a single term.
There's a single term. You can only square root whenever it's a single term.
Correct.
Bro,
This is next year.
That fucking buggled me, bro.
That's why I'm just telling you why you can't break this apart.
Okay.
B squared is a perfect square, but this isn't. And because they're separate terms, you don't ever do it when you have multiple terms.
Even if
What
it
are
was,
we doing all that?
I'm fixing to. I'm about there. X is not by itself yet because X is being added to B over 2A, which means I need to subtract B over 2A. So this is going to equal X equals, that's a negative B over 2A when I subtract it, plus or minus the square root of B squared minus 4AC over 2A. And now these two fractions have a common denominator, so I can simplify it just like I did when I simplified here. I can write this to be X equals, because it's a single denominator, that's going to be negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Writing it over its common denominator of 2A. This is what is called the quadratic formula.
So that would be the answer.
That's the third way that you can solve it, is you can use the quadratic formula.
So that would be the answer. is the x equals whatever that is. All that.
You're not going to have to find the quadratic formula again. It's always this.
Yeah.
I'm just showing you how to find it. We've derived a formula. Yes.
Wouldn't there be two different answers because you're
You're a genius.
I don't feel awkward.
Okay.
who's ever invented
So when we look at this one, this is a quadratic. And if I'm trying to find the solutions, the roots, the x-intercepts, we could try three things. Number one, you could try to factor this. What multiplies to be 7 but combined is -4? Doesn't work. You could complete the square of this. It would work. It would take a little time. We're going to choose to use the quadratic formula instead, which is up there on the board. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So look at this formula. Look at this quadratic. What is the a term? The a term is 1. What's the b term? -4. Remember, the sign in front of the number goes with it. So b is -4. What is my c term? -7.
Holy crap.
So now we're just going to take that and plug into the formula. So the formula has a built-in negative, right? -b over 2a. Does that look familiar? Negative b. So that's going to be a negative. What is my b term? It's -4. So what is -4? I'm just gonna plug it in like this. -4. Then there is a plus or minus the square root of b. b is -4 squared minus 4 times a, which is 1, times c, which is -7.
If you didn't put the first -4 whenever you square it in parentheses, would it be an error on the calculator?
All over 2 times a, which is 1. So for me, what I would do is I would add 4x to both sides. And so now that's going to be 21 equals x squared plus 4x. Right? And then subtract 21. So now I've got 0 equals x squared plus 4x minus 21. And now I would plug those into the quadratic formula to find the x-intercepts. So,
Discrimination.
no, discriminant. You can determine the number of solutions of a quadratic equation without solving it. In the formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is b squared minus 4ac.
Why is it discriminant?
That's what they call it, is the discriminant. The discriminant will tell us how many real solutions the equation has. The solution of a quadratic equation is also called its roots, its x-intercepts, its zeros.
Solution.
All the same thing. Roots are the input values for which the related function is 0. So if you plug in and b squared minus 4ac is bigger than 0, then there are two real solutions. So this would be the first note I would write. If b squared minus 4ac is bigger than 0, there are two real solutions. If b squared minus 4ac equals 0, that means there is one real solution. And if b squared minus 4ac is less than 0, there are no real solutions. What's this relating to? This is talking about the number of x-intercepts. Remember the graphs I drew at the very beginning of class? A parabola can touch the x-axis 2 times,
One time or
1 time, or
no time?
no times. And this is how we can find out how many x-intercepts there are without graphing it, by using the discriminant. When I look at the second one, when I look at this one, it's graphed, so I see it should only have 1 x-intercept. But if I didn't know, I could plug in and find the discriminant. B squared minus 4ac. This time the b term is positive 4. So 4 squared minus 4 times the a term, which is negative 1, times the c term, which is negative 4. Right, this is my a, b, and c.
Wait, would you ever have to like
Divide by a negative with that, like when you're trying to solve that and try to find x, would you divide by negative? Like divide everything by negative to get x to be 1?
You can.
Right? I mean ax squared.
You can.
But can you not just solve it like that? Because ax squared is negative 1 x squared.
Yeah.
What would happen if you tried to solve it with that instead of 1 x squared?
You try to complete the square, or what are you
Yeah.
saying? Yeah, you have to divide everything by negative 1
Okay.
if you're completing the square.
Yeah.
We're not completing the square though.
Yeah.
We're just finding the
Right,
discriminant.
if you had to, yeah.
Yeah. So this would be 16. 4 times 4 is 16. And then a negative times a negative times a negative. It's going to be negative in the end. So 16 minus 16 is 0. So the discriminant is 0, which means there is one solution.
Which is the vertex.
Right, the x-intercept's on the vertex. The last one. This one, it is going to be no solutions. We could plug in to find the discriminant, which is going to be b squared. That is negative 4 squared minus 4 times a, which is 1, times c, which is 5. This would be 16 minus 20, which is negative 4. So because this is less than 0, because it's negative, that means there are no solutions.